What if gravity isn't the smooth curvature of space-time as we've always been taught? General relativity paints space-time as a smooth fabric, with mass and energy bending it. Planets and light move along the straightest lines on this curved surface, and the event horizon of a black hole marks a perfect boundary beyond which light cannot escape. This elegant picture works well, but it hides two crucial assumptions. First, the existence of a medium beneath this curvature is ignored. And second, the curve is assumed to be infinitely divisible and perfectly smooth, which doesn't hold in quantum mechanics. In energy filament theory, the foundation isn't geometry, but a sea of tension that can be stretched, wrinkled, and textured. Gravity, in this view, is the large-scale slope of this sea, a transition between areas of high and low tension. If we blur the details, this tension slope looks like a smooth curve, much like the geometry in relativity. However, what's actually bending is the tension slope itself, which has granularity and roughness that becomes apparent in areas with extreme gravitational fields, such as near black holes. When you approach these extreme gravity zones, tension reaches its limits. Even the smallest disturbance can cause tiny patches to misalign, forming a tension pore. In energy filament theory, this process mirrors quantum tunneling. The gravitational or potential barrier is just an average appearance, while the underlying structure is a finely tuned tension skin. When a disturbance occurs, it causes a brief misalignment in the tension, creating a short-lived pore through which particles can pass, much like how particles in quantum mechanics tunnel through barriers. The black hole event horizon, in relativity, is seen as a perfectly smooth line that light cannot cross. But in energy filament theory, it's a steep tension skin where tiny pores flash and close, allowing energy and information to leak out. What appears as black hole evaporation in relativity is, in this view, a continuous process of energy leakage through tension pores, a phenomenon visible as the leakage effect at the event horizon. In essence, energy filament theory provides a more granular and unified explanation of gravity, showing that it's not just about a smooth curve but the dynamic interplay of tension in different scales and configurations. It also explains phenomena like quantum tunneling and black hole evaporation along the same framework of tension and texture. Tap follow, share it on New Physics, Clear Universe.